Welcome once again, students. It is the video number 4 of that Newton's laws of motion. And what was in that video number 3? A quick recapitulation we will have in that. In that video number 3, I have started the impulse and momentum. So guys know that a force is the rate of change of moment. Rate of change of momentum is nothing. Force is equals to the change in momentum divided by change in time. Time rate of change of momentum. So that time we are bringing to the left side. So that will become F times del T, and it will become the change in momentum on the right side. So this quantity F times del T we will call as our impulse, and it will be our vector quantity. And this impulse I can write when as equals to that capital F vector times del T when the force is constant, and when the force is variable. In the case of variable force, what will we consider? We will consider the average of that variable forces, and we will write the impulse as equals to that F average times del T for the variable force. And we had seen that means if a variable force is acting here, you are looking that for when the time is changing, our force is varying. I was saying that we don't consider average here because it will be that variable. When you will take the average, then you can write. For the time you can write for your understanding. Okay, so that average, here we are saying that average times del T, and here we are saying means that we were getting the graph of that impulse, force time graph we were getting, and were saying that area under the FT curve. Area, what will become area? That length into breadth. You can say that length into breadth. So that area F times del T. That F times del T is what? Or F times T is what? The impulse only. So the area under the FT curve is going to give us impulse, and it is not going to depend upon the nature of the curve. It will only depend upon the what is the area you are getting. That impulse will depend upon the area under the FT curve. So whatever area we had got in the case of that variable force, the same area I can draw for that constant force. So that constant, for the same area we will draw for that constant force, and we can measure the what is the average force by this expression that we had seen. Next we had moved to that what is the unit of that impulse, represented by capital I vector. So that SI unit was that kg meter per second, to which you can write as our Newton second as well. CGS system, gram centimeter per second it will become, and also student you can write that as our dyne second, isn't dyne second also you can write. Then we were talking about that Newton's third law of motion. It is very important to define it correctly, and I have told you this much of the statement to keep in your mind, that what is Newton's third law, that when two objects interact with each other, then the force by what? It is force by particle 1 of object 1. Force by particle 1 of object on particle 2 of object 2, and the force by particle 2 of object 2 on particle by particle 2 of object 2 on particle 1 of object 1 are equal in magnitude but opposite in direction. And they will act along the same line of action, or line joining the two particles. Suppose we have the two particles here, okay, of the object 1 and object 2. So this particle is applying this force on that particle 2 due to the 1, force on the particle 1 due to the 2, and whatever that force they will apply to each other, they will be equal in magnitude but opposite in direction, negative side. Negative means left will become right, up will become down, clockwise will become anti-clockwise. Negative sign will represent in that physics that it's the direction. In mathematics as well, it's the direction only the negative sign is going to tell you. And listen student, that if you are drawing these forces in this way, so it will become wrong because they are not acting on that same line of action. That forces should act on the same line of action. And next important point of note was that force is by the object on some other object. Please keep this in your mind. That your Viva master can ask to you, Miss Viva teacher can ask to you these things, and you will become that. If you are saying these things, he will become impressed to you. So force is by the object on some other object. Keep this in your mind. And then after we had moved for that law of conservation of linear momentum. And what was that law of conservation of linear momentum? If no external force is acting on any system. Okay. Listen students, system you will study in that thermodynamics, open system, closed system, isolated system. So these system will come in there. I will discuss that these things there. For a time you can say system, any system means you can say it's not the system of present means. Now you may get confused that system is that our politics, that system of that state, system of that country, system of that capital. No, that not the system. Okay, please keep in your mind. It's not that system. It's the system we are talking. Now, if we are saying a system, a pulley string arrangement, a block, two block arrangement, that system we are talking. Don't get confused with the system of that our country. So if no external force acting on that system of constant mass, having the constant mass, it will be closed system, means that mass can't vary. Mass can't vary in that case. Whereas you will say that in open system that mass can go from one place to the other place. But when you are saying that a fluid is flowing, so that particular mass will go from one place to the other place. It is not happening there. Mass is confined at one place. It is our closed system. So if no external force acting on the system of constant mass, okay, the total momentum, what is the total momentum of the system will remain constant. The total momentum is going to be remain constant. Okay, so if this is the force we are getting, what is force? That rate of change of momentum. And if no force is acting, so F will become 0. F will become 0, meaning is that derivative of momentum with respect to the time will become 0. And what I have told to you, if differentiation of any quantity with respect to any other thing, or you can say for the time with respect to the time, or differentiation of any quantity is coming equal to 0, so that quantity will become constant, because the differentiation of constant thing will be 0 only. So if this force no external force is acting, so that momentum will become constant. And for the system having the particles, so many particles, that from 1 to n, that total momentum will be constant. So we can say that momentum of particle 1, particle 2, particle 3 up to the particle n will be remain constant. And what is momentum? Mass times what is momentum? The product of mass with velocity. So m1 v1 plus m2 v2 plus m3 v3, it will become constant for a system when no external force is acting on the system. And we have seen that for a two particle system, if you are looking that only two particles are present in our system, any system you are saying which is closed, having the constant mass, so that momentum is constant. So momentum is constant, meaning is that mass times velocity plus mass times velocity of that particle 1 and particle 2 will be constant. That will be equal to, here not 0 will not come, I am sorry student, here it will be constant. Okay, it will be constant. Okay, and when will we differentiate it with respect to the time? So what, the mass is constant, so mass will come out, del v upon del t, change in velocity upon change in time will give us acceleration, so mass times acceleration. Then m2 will come outside, del v2 upon del t means that change in velocity upon change in time will give the acceleration of that particle 2. And when will we differentiate the constant? Here that differentiation of constant will become 0, and that m1a1 will become equal to that m2a2 with negative sign. Okay, with negative sign it will be there. So m1a1 will become minus a minus m2a2, and what is m1a1 is the force acting on that particle 1, m2a2 what is this force acting on the particle 2 with a negative sign. So what is it? It is the consequence of the Newton's third law. It is the consequence of the Newton's third law, and we have seen that when a system is there and having the particle, so many particles from 1 to n, for any particle if you are considering here, any particle you are considering, all the forces acting on this particle now due to the other particle which are inside this boundary or inside this system, so they will become equal and opposite to each other and they will get cancelled out. Once again, that whatever force will act on this particle due to the other particle. No, don't say that a force will also act due to this particle as well. No, a force is not going to act on this particle due to this. Okay, because that force is by the object on some other object. A force we can miss this on this particle. There will be no any force due to this particle. Due to the other particles there will be the force on this particle, and the force due to the other particles will be equal and opposite, and they will get cancelled out, and only that force which can act on this particle is the external force. Getting? So it was the Newton's laws. We have studied, and we shall move for that application of Newton's third law. You can have this screenshot up to here. You will remember there was that constant here. You can change that. So now we are moving for that applications of Newton's third law. So applications of Newton's third law. You all guys know that now that jumping of a man, we can have that jumping of a man out of boat on the shore pushes the boat slightly away. You all guys will be aware about it, Means if this boat is here, okay, we have a boat here, and if a man is he is that coming on that some platform, this is platform present here. So if a man is jumping from that boat, a man is here which is jumping on that boat, so this will that go in that, or it will move it slightly away from it. Means what is here is that action is taking place, and here what's going on, reaction is going on. Okay, and this action and reaction, please no, this will be on that same line of action. Okay, same line of action. So it should be on that same line of action. So it's better to draw it so that it can look on the same line of action. Okay. So these points you guys will keep in your mind, and this will be equal in magnitude but opposite in direction. We can have one simple example of it. Okay. Next is student, slightly okay. Next we will move for that recoil of gun. Next application we will look that recoil of gun. Recoil of gun. So we are having a gun. Here we are having a gun here. And that we are shooting and the bullet is coming out from it. Where is that? You can have that trigger. Okay. So what are the various things in it? First we shall move for that. You can say let small mg is that mass of gun, is the mass of gun. Small m b we are representing the mass of bullet, and small vv we are saying as our velocity of bullet. Velocity of bullet, and a small vg we can say as our velocity of gun. Okay students, in this student, now you will note down one thing, that in bullet gun system, the force exerted by trigger will be internal force. It will be what? Internal force. Don't confuse that it will be at our external force. It will be our internal force will be there, because by pushing that means whatever force is going, that the system present inside that gun, so that will be that our internal force. Okay, whatever the mechanical system will be present there, that will be that internal force. So momentum of system remains unaffected. Okay, that momentum of the system is not going to change. We know that our initial momentum was equals to 0, and what can you say about that final momentum? final momentum will become what? This mass of that gun and velocity of that gun plus mass of that bullet and velocity of that bullet. Is it? It will be our final momentum. Mass of that gun with velocity of the gun plus mass of the bullet plus velocity of that bullet. Okay? So, from the law of conservation of linear momentum, what the law of conservation of linear momentum will tell? That total momentum will remain constant, is it? So we can say that our initial momentum, total momentum will be constant. So what is the meaning? That whatever was the momentum at the starting time, the same momentum will be there for the final time. So our final momentum, you can say final momentum, since it is constant, is equal to that our initial momentum. Okay, initial momentum. And what is that final momentum we are getting? mg vg plus mb bv vector here, and initial momentum was what? 0. So this vg we will say from here, what can we say? Mass times that vg will be equal to what? Will become minus mass of that bullet and velocity of that bullet, isn't? And from here what will we get? That velocity of gun. What is that? Velocity of gun is nothing but the mass of the bullet divided by mass of the gun and velocity of that bullet. Okay? Any confusion? I don't think there should be any confusion. Velocity of gun, negative sign will be opposite to the velocity of that bullet. In whatever direction that you will, that your bullet is going to move in the opposite direction, you will have that velocity of gun, and this will be called as our recoil velocity. It is what, student? It is called as our recoil velocity. Okay? Can I have this screenshot up to here? So we are getting this expression here, and we will look what is the observation here. I am rubbing this side. So observations. What are the observations we are getting from here? First observation, we are saying that negative sign indicates that the velocity of recoil, what is velocity of recoil? Vg, velocity of gun, is opposite to the velocity of bullet, and velocity of that bullet is what? V, capital V only. So whatever will be our recoil velocity, that will be in that opposite direction of that velocity of bullet. This first observation we have seen, and second observation, student, what can we see? That whatever is our that recoil velocity of gun, that velocity of gun is inversely proportional to that what? Mass of that gun, isn't? This Vg is inversely proportional. If this velocity of that mass of that bullet and velocity of that bullet is constant, so that our velocity of gun is that inversely proportional to the mass of that gun. Okay, so that for a person holding the gun to his shoulder, this you guys will look that velocity of that gun means that recoil velocity of that gun will become what? 1 upon that mass of that man plus mass of that gun, isn't? If you are holding that gun to that to your shoulder, so that whatever that mass of that gun will become attached to your body. So in that case, our recoil velocity will become inversely proportional to the mass of that man and mass of that gun, and that we can save the, so person can save from hurting by holding gun to shoulder. Okay, so this we will see that from that our expression which we are getting for that recoil velocity. Okay, so person can save him, can write by holding gun to shoulder. Okay, this observation we are getting here. And next observation we can see from here is that higher the mass of that gun, higher the mass of that gun, low is the recoil velocity. So our recoil velocity will become low when that our mass of that gun is that high. Okay, so in place of low you can write that lesser as well. Lesser is the recoil velocity. So if that mass, that our gun is that heavy, so that we will feel less recoil. If that our gun is that that have lighter mass, so that more recoil it will give to us. Okay, you can imagine by holding the gun in your hand, when you will hold that, you will look that how much heavy it is. Okay, so if a lighter gun you are getting, so that you will feel more recoil of that. So these things are there in that application of that Newton's third law of that gun system, gun and bullet system we are looking. And next we shall move for that rocket system. First can have this screenshot up to here. So we have seen that our recoil of gun, and we shall move for that our rocket propulsion now. You guys will have that experiment of that rocket. I think you might have done that experiment in your class. So it is the rocket here we are seeing present. So action reaction will be there, isn't? And when you guys will go for that DRDO and that ISRO, that class rocket will become that practical rocket there. So keep on that doing like that. So let M note is that initial mass, we are saying initial mass of the rocket. Initial mass of that rocket. M we are saying the mass of rocket at any instant t, instantaneous mass. So at any instant t, what is the mass of that rocket? Small m. And small mr is representing, student, that mass of, not mass, residual mass. What? Residue that which has been left, residue in chemistry. So residual mass of the container is residual mass of the container of the rocket. Okay, and we are saying u vector, small u vector is representing that our velocity of rocket, velocity, no, not rocket, velocity of exhaust gases, velocity of exhaust gases, and capital V vector is representing the velocity of rocket, student. Okay, so from here that fuel will get burned and that exhaust gases is coming out. Okay, exhaust gases is coming out with that velocity of VU, you are saying, and rocket is moving that upside from that Newton's third law, you guys will be aware, with the velocity capital V vector we are saying, and it is the mass of that small m, we are saying the mass of that rocket at any instant t, and this capital V you can say velocity of the rocket at instant t, or you say you will be aware that instantaneous velocity. Okay, at any time we will say that what? Instantaneous velocity. Otherwise what will we say? Average velocity. Remind that your 9th class. So that exhaust gas is actually, student, now means you guys will have a kind of that engine present in that rocket. A compressor will be there. It is that compressor is there. It will take the air, that atmospheric air it will that take, and it will compress that atmospheric air to that high pressure and high temperature. It will compress, that compressor will compress that, and that air will go to that combustion chamber. Okay, combustion chamber, and from here that fuel will come. Okay, fuel will come, and that air is required for that burning of that fuel. So that compressed air we are sending to the combustion chamber, so that fuel will get burned, and it will come to that. It will come to that what? A turbine. A turbine will be there. Okay, turbine is there. We'll study these things in thermodynamics. So these gases will expand. These gases will expand on that blades of that turbine, and when it will expand, it will provide a kind of that thrust, and our turbine will start rotating. So here we will get that rotational energy of that turbine. So for that an engine, we have requirement of that rotational energy. So this kind of the things we are getting, and from here when these gases, that fuel with that gases will that expand on that turbine, it will exhaust, it will get exhausted to that atmosphere. Okay, we can have the idea from here. Okay, so that that cryogenic that engine we used in that our rocket, I think cryogenic, I think you can check for that. I think cryogenic will be there. So that exhaust is that kind of that exhaust is going out. So that exhaust we are saying exhaust of gases. For the time you can ignore that also, that is not present in your course. I have given you some kind of that idea present in it. Okay, so you will look kind of this kind of that engine will be there. So this is present there. So that exhaust gases will apply some force on the ground of the earth, and earth will provide a thrust because of that Newton's third law, that exhaust gases will apply some force on that ground of that earth, and earth will provide a kind of the thrust to that rocket. This we will look in that rocket propulsion. Okay, you can write up to here, then after we are moving for that other thing also. So we are getting such kind of the situation here in that rocket, and we are looking mass is varying due to that burning of fuel. Mass is varying. So that we will say that dm upon dt is that rate of change of mass of rocket. Rate of change of mass of rocket, and we can also say that it is the rate of consumption of fuel. What? Rate of consumption of fuel. That according to that our mass will vary. So rate of consumption of fuel, or you can say that rate of ejection of fuel. Okay, so we are ejecting fuel in that combustion chamber. So at what rate we are ejecting, that will depend upon the varying mass, that mass of that rocket. According to that our mass will vary. So student, what are the different forces which will act on that system, that act on that rocket at particular instant of time t? We are choosing a fixed time we are looking, and that our rocket is still, there is no movement in that rocket. So what is that forces acting on that? It is not accelerating at that time, you can say. So at any instant, t we are saying. So what is that? Forces will act. What are the forces acting on it? The first force you can say is that weight of that rocket. At instant t, mass is our small m. So weight will act in that downward direction due to the gravity. Okay. Next force which can act on it, is that F exhaust. Okay, F exhaust. Okay, these will be on that same line of action. We can shift the vector. So that's why for your understanding I have drawn like it. And kind of that, now you can say that it is the particle like it. Okay, now it will become easy to understand to you. Okay, if exhaust is acting in that downward direction, weight is acting in that downward direction, and because of that exhaust of that gases, our rocket will have a kind of that thrust force. What? This will be F thrust in that upward direction. Because of the Newton's third law, exhaust gases will apply the force on that ground, so ground will apply that force on that rocket, so that thrust will produce in that rocket and rocket will go up. So at particular time t, that when the rocket is still, so that what are the different forces acting on it, we are drawing that. Next force we can say as our F drag. What? F drag. What is F drag, student? Due to that air friction, when it will move up, so air that will provide a kind of that friction to it, friction it will provide, so that drag we are saying as the force of drag, and that drag will be due to that air friction, and other gases friction also can be in that. Air is that combination of that gases, so that drag force we will not consider here, but for the time we will also say that a drag force will act in that downward direction, because that movement is in the up direction. So in that opposite direction of that motion, so friction force always act in that opposite direction of that motion of the object, so that it is the drag force due to the air friction, so it will act in that downward direction since our rocket is going up. So these will be only forces which will act on it, and please student, you will not say that a normal force will act on it, because now at time t there is no contact present in that. There is no contact of the rocket to the ground, so that at instant t normal force don't make the blunder of that making normal force on it. Okay, only this much forces will act on it. Can write up to here. So we have come to know what are the forces acting on it. I am rubbing this side, student. So student, by Newton's third law you guys will be aware that for every action there will be equal and opposite reaction, and of course this F thrust will be what? Equal in that it will be not equal in magnitude. That we will say that it will be equal, that F exhaust here with a negative sign, which meaning is that at whatever direction exhaust will take place, F thrust will act in that upward direction. Okay, so F thrust should be greater than that rocket will move up. Okay, so that mass is that varying, so F will will become more in that case, and that exhaust gases is going out of that air, so our F thrust now will come more in that case. Now you will look for that rocket, they will be not equal in magnitude. You guys will notice it. If they will be equal in that magnitude for a particular time t, we can say they are equal, and of that at any instant when that rocket is still, so we will say that F thrust should be equal to what? minus of that F exhaust, at this time they can be equal and opposite. Now because we are at particular instant of time t we are looking at, there is no acceleration, we are assuming at that case for our study, but it will accelerate that with some certain acceleration, and that F thrust will be that more, then only it will move up. Otherwise miss your rocket is not miss, rocket is not as your rocket. If it is not going escaping that earth, then whether it will be that rocket, I don't think so. F thrust will be more, but for particular instant of time t we will say that this will be situation, and our F thrust should be equal to that what F of exhaust with a negative sign, that from Newton's third law. Okay, and if you are also that where we are neglecting you can write from it, neglecting the weight of rocket and air drag. There is no air drag present there. So what this exhaust force will be there, student? This exhaust force will be equal to what? Small u times dm upon dt. Force is what? Rate of change of momentum. So this is our v, small u velocity, it is going down, and mass is varying with respect to the time. So dm upon d momentum time divided by del t means that change in momentum upon change in time. So mass will vary. So when that mass will vary, so momentum will change. There will be initial momentum, final momentum of some variation of that mass. It's very small variation we are looking, but for very small we will have that instant t. I will talk about this for very small variation of that mass in del t time. So what is that F exhaust will be this, it is kind of the rate of change of momentum you guys are looking, isn't? And this will be equal to our, and a negative sign will also come here, student, and this will be equal to that F thrust. Okay, this will be equal to our F thrust. I'm rubbing this side. And student, if you are saying that when weight of rocket is also considered, and that weight will also consider, you will that your F thrust, this F thrust will become this minus u times del m upon del t and minus of mg. Is it? This downward weight is acting in the downward direction. So this minus sign will only say that F thrust in that opposite direction of that F exhaust. Okay, you can put a vector here, I think here as well. So you will say that negative sign indicates that thrust force is in opposite direction. Thrust force is in opposite direction of the exhaust of gases. Getting? And student, now if we are saying the acceleration of acceleration of rocket. So acceleration of rocket, F thrust will be what? Mass times the acceleration of thrust will become equal to what? This minus u time this del m, variation of that mass with that change in time, minus m time g, and from here you guys will get a acceleration of the thrust will come out minus u times m, it's not u times, minus u by m del m upon del t minus of acceleration due to gravity g. Getting? This will be our acceleration, and I'm rubbing this side. Neglecting, if you are that neglecting the mass, neglecting the effect of gravity. Effect of gravity we are neglecting. So when that effect of gravity we are neglecting, our A thrust, acceleration of thrust will become what? Minus u by m times del m upon del t, and u, small u vector you will say. So this will become this. Okay, student? So student, we had seen that our expression of that acceleration of thrust of that rocket. So acceleration of thrust was coming equal to that what, minus u by m times the del m upon del t, and in the case of that that gravity is taken into account, our acceleration was coming with this u by m times the del m upon del t minus g, isn't it? Were only our expression which were we getting. Okay, it was the case that when gravity is neglected, and this was that when gravity acts. Okay, so these were the expressions we were getting here. And student, please, that A thrust, acceleration, student, how can we write that acceleration? Acceleration, student, we can write as our what? Change in velocity upon change in time. Derivative of that velocity will give us acceleration. So I am not writing V thrust here, as we have assumed at any particular time t, our velocity will be represented by capital V. You can write thrust as well for your understanding. Since I had assumed that there will be that capital V velocity at instant t, so I have written that capital V here only. So what it will come out? This del V will become, del V upon del t will become minus u by m times the del m upon del t minus g. Isn't it, student? What can be next thing? This del V, this del V, this del T I am taking to the other side. So it will become minus U by M times del M upon del T minus of G times del T, which will give us what? This minus U by M times del M upon del T. This del T will get multiplied here, del T here, and minus of G del T we will get. And this del T will get cancelled out, student, and we will get the expression of that velocity, this derivative of that velocity, change in velocity, it will become equal to minus U. It is not changing. The terminal velocity is what is the terminal velocity, starting velocity we are giving to the rocket, that is not going to change. So that will remain constant throughout. So this del M upon M we can write, and here it will become minus G times del T. So this is a student that del V here, very small change in velocity, and now what will we do? We will integrate it. We will integrate. You know that opposite of differentiation is integration. Very small thing we have come to know. If we will integrate that, we will get whole thing. So we will integrate it. I have told you that in the previous video. From time t is equals to 0 to time, suppose, t. We are integrating this del V. So here also it will become that from time t is equals to 0, time t is equals to 0 to time t is equals to t, minus U by del M upon M, and minus of that when time is equals to 0, when time is equals to t, time is varying from 0 to t, minus G del T here. Okay? This expression we will get here. And look, student, that our dx, integration of dx will become x. Note, integration of that dx will become x. It is that formula of integration which will apply here. So you will look that del V, when we are integrating, so it will become what? Capital V. Differentiation and integration are opposite. So this differentiation integration will get cancelled out, and what will we get? V at time t is equals to 0, at time t is equals to 0 to time t is equals to t, and that will be equal to what? This says that u is your constant, or it is not varying with time. So this u you will take outside, it is constant to the integration. And student, this del M upon M, it will become log base E of M. Log base E M to the time 0 to time t, and it will be give us what? Minus G, acceleration due to gravity is constant. It will become del T. When you will integrate this del T, what will come? T will come, and T is varying from that time t is equals to 0 to time t is equals to some t. Getting? You will note this. Integration of del x upon x is what? log base Ex. Okay. So integration of that del x upon x is log base Ex. So that integration of del m upon m will become log base Em. These are the integration formula which we are applying here. I hope you guys have understood. Can write up to here. Then after we are moving for the next thing. So student, we have got this expression by integrating. Now we will put the limits. So when will we put the limits in that integration, you guys will look that it will be upper limit minus lower limit only. Okay, upper limit minus lower limit. So it will become velocity at time t is equals to that instant t minus velocity at instant t at time t is equals to 0, and this will come out equal to, student, minus u times this log base Em. So our log base Em at particular time instant t and minus of log base Em when the time was equals to our 0. At this minus g, this time t, this t we will write t when that time t was equal to instant t, and time t, this when time t was all equals to 0. Okay, and student, you guys will look, there is no velocity of that rocket at the starting time. At the starting time, there is no velocity of that rocket. So that expression will become equal to 0, and here we will get that this velocity of that rocket at particular instant t will be equal to capital V, we have assumed, and this minus u is that exhaust velocity of that gases, and mass of the rocket at particular instant of time t we had assumed that is equal to nothing but the m only, minus this mass of the rocket at the time t is equals to 0, starting mass, initial mass of that rocket that we had assumed as our m naught, and here minus g, this time t at instant t it will become t only, and time when time t is equals to 0 there is 0 time. Okay, so t minus 0, you can say the starting t is 0, so this 0 at instant t we are saying time t, and this velocity we will get. Next, what can we do? This minus sign we can bring in the inside of it. So this, when that minus sign will come inside of that bracket, so it will become log base Em naught minus of log base Em, isn't it, student? This minus will make it minus, and this it will become plus, so plus minus. Okay, and this will come out g times t, and student, that our velocity here will become u times this log base Em naught upon m minus g upon t. Okay, is the velocity of that rocket at particular instant of time. The expression of that velocity we will get like this, because we will integrate the acceleration, or that acceleration we will write del v upon del t. So when you will integrate del v, that velocity you will get, small velocity will become that some value of that you will get, and you will note, student, that log m minus log n is nothing but the log m upon n only. Okay, so this log m minus log n. At the place of m and m naught and m is present, so this will you will get. Okay. And you can say if that you are neglecting the gravity. When are you neglecting the gravity? So neglecting gravity. So that velocity of that rocket will become this u times log base e m naught upon m only. Okay, gravity you have neglected. So these are the expressions of that velocity, acceleration, forces we are getting in the case of that rocket propulsion. And you will remember these things. Okay. We'll talk more about it. First write up to here. You can take this screenshot up to here as well. So student, we were getting the expression of that velocity of the rocket at any instant t, that was equals to our exhaust velocity of the gases and log base e m naught times m naught divided by m naught by m. So it was the expression which we were getting. And when you will student will change the base of that log e in that base of log 10, so you will multiply this expression by 2.303, and here that base of that log will change from exponentials to that log base 10 times the m naught by m. Getting? So when that base of that log you are changing from exponential e to that base 10, so you will multiply the expression by 2.303. It is the task of your mathematics. I am not going to do that, and that is not very important for you as well for your exam point of view. No one is going to ask that conversion of that. It's the mathematics task. Now when you will study, you can do that. Do it there. So when you will change the base e to the log 10, so you will get the expression. You will multiply the expression by 2.303, and when you are saying when gravity acts, so when that gravity will act, so your expression, this expression will become this. Velocity will become 2.303. Here that log base 10 we will get, and m naught upon m and minus of gt we will include in that. No one will do the blunder of multiplying this 2.303 to this gt. Getting? No one will multiply this 2.303 with this gt. Getting? It will be multiplied with this only. So this you will keep in your mind. Next we shall move student for that burnt out speed of rocket. Burnt out speed of rocket. So what is the burnt out speed of rocket? When all the fuel or propellant will burnt out, then rocket will move with maximum speed. Okay, so when all the fuel will burn out, so that mass will become lighter and that velocity will become highest in that case, according to the law of conservation of momentum. So when we are saying when our m, that mass of that rocket at any instant is coming equal to that mr, residual mass of that container of that rocket. So when m will become mr, then our velocity of that rocket will become v max. Velocity, you can say speed in particular direction will become velocity, and the expression of that you guys will get, student, that v max will be equals to your u. Okay, here u also you will include, no? Sorry, here this will be equals to u times. Okay, u times you will do. Here also there will be u times. I have forgotten to put that u in this case. Okay, you will put there. Okay, now, so u times, it will become u times that log base e m naught divided by mr in this case. Getting? This m will become equals to mr, then you will have that maximum velocity, or you can say that 2.303 times u, and this log base 10 it will become, and m naught upon mr. This will be our burnt out speed. Okay, this will be called as our burnt out speed. Burnt out speed. Okay, student. So these are the things which was present in our that rocket. There are so many things in your rocket, but up to where you will have to be that study. There are so many things which we can talk about that rocket, but it is the only thing which is present in your course. So you will study up to here. Next, one more thing which can I give from my side is that escape. You can note down this. Escape velocity of Earth. What is escape velocity of Earth? Anybody is aware about that? It will be, student, that 11.2 kilometer per second. Getting? 11.2 kilometer per second. If you are providing the escape velocity, terminal velocity that to that rocket, it will go. The gravity effect will not act on it, and it will move out of the Earth. So you will remember this. So they can ask you this problem as well, and so many exam you will find that it will be that important for you. So up to here for today. Enough for today. Study well. Thank you all. Anything? Everything is correct now?